My name is Agustin Blanco, and today I'll be talking about the importance of matrices in computer science. When you first think about a matrix, the first thing that might come to your mind is the famous trilogy of movies about the chosen one, Neo, portrayed by Keanu Reeves. But truly, a matrix looks more like this. A matrix is a rectangular array of numbers, symbols, or expressions arranged in rows and columns. This rectangular grid of numbers is among the most common tools in electrical engineering and computer science. The numbers that are used in matrices can be represented by data or also mathematical equations. Matrices were originally created to describe systems of linear equations, but as technology has advanced, matrices have gathered more uses than what it was originally intended to. As mentioned, computer science benefits a lot from matrices, especially in the computer graphics area. Graphics use matrices to process linear transformations and render images as a result. Matrices can move objects in 3D spaces by applying operations in the vertices, manipulating them in the process. They can be done by a process called transformations, which has a total of 3 basic types: scaling, translation, and rotation. Scaling basically changes the shape or size of the object depending on the result of the matrix. Translation is when the object moves from one place to another while keeping its original shape. In other words, translation is equivalent of movement. And rotation is somewhat more complicated to achieve because it involves trigonometry. But what happens in rotation is kind of self-explanatory. It makes the object rotate. As mentioned before, a matrix is composed of both rows and columns. The rows are the horizontal entries, which means that the columns are the vertical entries. As you can see in this example, this matrix has 2 rows and 3 columns, meaning that its dimension is a 2 times 3 matrix. When solving systems of linear equations using matrices, the first step is to arrange the coefficients of the given algebraic equations. Once the coefficients have been placed properly, you have to transform the matrix into reduced echelon form, which means that it must be simplified with only zeros and ones. Basically, the reduced echelon form is used to get the numeric value of each variable used in the system of linear equations. This is done by playing with the rows by multiplying or subtracting between each of them, until you end up with only zeros and a diagonal line of ones from each corner of the rectangular array. As you can see, in the following example, x is represented by a 2, y is represented by a -1, and z is represented by a 3. When adding or subtracting matrices with the same dimension, it's quite simple. You just simply need to add the entries with the same term. Now, you might be thinking, how to add or subtract matrices with different dimension? So the answer to this question is you can't. If you try to add or subtract matrices with different dimensions, the answer will always be undefined. Matrix multiplication is probably the most essential use of matrices as a whole, as for it is used to solve many different types of real-world problems, especially in the computer graphics department. So, how do you multiply a matrix? This time, it is not as simple as just multiplying entries directly, as we did with addition. What you need to do is take the first row from one matrix and multiply it by the first column of the other matrix. Then you need to add them to get the first entry. Then you do the same process, but this time you multiply the first row with the next column to get the next entry, and so on. Once you finish multiplying the first row, you need to go to the next row and repeat the same process over and over again until you get all the necessary entries. Now, the following example shows us how to multiply a matrix with the same dimension, but then you might be wondering, how do you multiply matrices that have different dimensions? First of all, if one of the matrices you want to multiply doesn't have the same number of rows to the same number of columns of the other matrix, then it's impossible to achieve an answer. In the case that this condition is followed, then you just need to do the same process as to multiply a matrix with the same dimensions. That's all the basic things you need to know about matrices and how they may be applied in computer science. Thanks for watching, and I hope you have a good day.